Alright everybody, welcome to our first SIMPLSharp video. The first thing that I want you guys to be aware of is that this is SIMPLSharp, not SIMPLSharp Pro. In SIMPLSharp Pro, you could just write all your code, compile it, and then pass it to your processor. But in SIMPLSharp, things are a little bit different. We have to get into Visual Studio, write all our code in SIMPLSharp, compile that. Then we're going to build a wrapper around that SIMPLSharp code in SIMPL+. We'll compile that wrapper, and then pass that wrapper over to Simple, which we will then compile again, and then we will pass that on to our processor. And the program that we are going to be making in this tutorial is the game of life. And it may seem like it's a little esoteric, and I guess it kind of is, but what's nice about it is that it's going to introduce a lot of the core concepts of the C# and SIMPLSharp programming language. So what is the game of life? Well, you start off with this grid, and inside of the grid you have live cells and dead cells. And what you do is you update the state of these cells from generation to generation by looking at 4 very simple rules. So the first rule is if a living cell has less than 2 live neighbors, the cell dies. If a living cell has 2 or 3 live neighbors, the cell lives on to the next generation. And if a live cell has more than 3 live neighbors, the cell dies in the next generation. And then a dead cell can come back to life if it has exactly 3 neighbors. Alright, so that's a very brief overview of the game of life. Now let's actually get into the programming. So you're going to open up your Visual Studio with the Crestron SIMPLSharp SDK installed, and you're going to go up to the top left, hit New Project, and under Visual C#, you're going to hit Crestron, and you're going to add a SIMPLSharp library from the templates. And I'm going to give this the name GOL Tutorial, but you can call it whatever you want, really. So whenever you're ready, go ahead and hit OK. So when you make your new SIMPLSharp library, Visual Studio is going to give you some basic stuff to work with. It's going to give you a namespace, it's going to start off the class for you, and it's going to give you a default constructor for your class. If you're not very familiar with object-oriented programming, check out the link here. For what we're going to be doing today, knowing all about objects and inheritance and all that kind of stuff is really not that important. All you need to know is that we're going to use this class and the SIMPLSharp libraries to actually do the hardcore game of life stuff. I'm going to change the name of this class to GOL, and I have to change the name of the constructor to match the name of the class. Alright, and then the last thing I'm going to do is actually change the file name of this guy by going over and right-clicking and renaming it. So SIMPLSharp is going to store information about the grid and whether the cells on that grid are alive or dead. And since I'm doing this on an RMC3, I'm going to use a really small grid of 15 by 15. So I'm going to set up a private constant integer whose size is 15. So this private part at the beginning just means that we won't be able to access this variable from inside of Simple+. Now the next thing I'm going to add is a 2-dimensional array that will store the state of each of the cells. And again, we're using the private heading because we don't want Simple+ to be able to modify this directly. The Boolean variable type is like your digital signals in Simple. It's either true or false. And then this new keyword here is just telling us that we need to set aside new memory for this double dimension array. So in addition to keeping track of the current state of all of the cells, I also need a way to keep track of what the cells are going to be like in the next generation. And you'll notice that I'm setting the size of these booleans to 15 by 15. Okay, so good, we've got our variables created. Now we need to go into the constructor and initialize them. Add a little space. The constructor is typically used for initializing the variables that you've got defined inside of your class. So I'm just going to add a couple for loops to make sure that both of our Boolean 2-dimensional arrays are initialized to false. So what this is doing is starting us off with all of the cells being dead. So what should our next step be? Let me open up the demo that I've got running already and we'll take a look and see what's going on. So this is our X panel that we're going to be using, and in order for us to be able to play the game of life, we've got to be able to change the states of the cells inside of this grid. So what we want to be able to do is click on any of these cells and toggle their states, which means that if we receive a row and a column location for an individual cell, we want to be able to change the state of that cell. So what I'll do inside of SIMPLSharp is make a new method that is going to set our cell state. So we made this public, which means that we want it to be accessible through Simple Plus, which makes sense because when we're in Simple Windows, we're going to be pushing inputs on the X panel, and we want those to go through to Simple Plus and then to go through to SIMPLSharp. We're going to return nothing from this function, and we're going to take in a row and column location of the cell whose state we want to change. So we'll take the cell at this location, and we'll assign it to be the opposite of whatever it was beforehand. And the exclamation mark operator here is just a not. Cool, so that's all we have to do to set the cell state. Now the next thing that we want to be able to do is clear the entire grid. So if we're doing a simulation and we hit the clear button, we want all of the cells to go to the dead state. So we'll create another function, and all that it's going to do is loop over every single element of our two-dimensional array and set it to false. So one thing that you'll notice that I do is looping variables. If they're not being used a lot, I tend to declare them inside of the loop statement, which is something that you can't really do inside of Simple Plus. And if you're not really familiar with C or C++ or anything, the for loop syntax is this. So this is what you set your counter variable to initially. This is the condition that you use to make the counter run. And then this is how you change the value of the counter as this condition is checked. So this outer loop, I'm starting at I equals 0. I'm checking to see if I is less than the grid size, and if it's not, then I increment I. Okay, so we're able to set the points on this grid, we're able to clear the grid. The next thing that we need SIMPLSharp to do is figure out what the next generation of cells is going to look like. So I'm going to make a new public function, it's going to return nothing, and it's going to take no arguments because we know that it's going to calculate the next generation for the entire grid. So the first thing that we need to do when we're calculating the next generation is we need to loop over every individual cell. And luckily we've already done this before, so I can just copy this code, the for loops at least, and paste it right here. And fix my indentation. Close those brackets off. We also need to check each cell's neighbors to see if they're alive or dead. So I'm going to define a new variable at the top of this function to keep track of the number of living neighbors that the current cell has. So before we start looping over the neighbors, I'm going to set the number of live neighbors to 0. And I'm going to add 2 more loops. In these inner 2 loops, we're looking at a 3x3 area around the current cell. This if statement basically blocks us from counting the current cell as being one of the neighbors. So what iNeighbor and JNeighbor are doing is kind of neat. So we're implementing what's called periodic boundary conditions. So don't worry about the math stuff, just worry about the programming syntax. Okay, so what exactly is going on in this code? In Simple Plus, if you're doing a comparison of two numbers inside of an if statement, you just use a single equal sign. But in C#, a single equal sign is used for assignment, and a double equal sign is used for comparison. And then the other weird thing that you probably haven't seen before is what's called this ternary operator. So what this is doing is we're incrementing the number of live neighbors by either 1 or 0, depending on whether the current neighbor is alive or dead. So this is really just a shorthand for saying something like this. If the current neighbor is alive, increment number of live neighbors. Okay, now once we've got a total for the number of live neighbors, we need to check with our rules of the game of life to see if the current cell is going to be alive or dead in the next generation. So the rules of the game of life are, if the current cell is alive, and if the current cell has 2 or 3 live neighbors, then the current cell is going to be alive in the next generation. But if the number of live neighbors is less than 2 or if it's greater than 3, so for all other conditions, the current cell is going to be dead on the next generation. If the current cell is dead, and it has 3 live neighbors, then the cell is going to come back to life in the next generation. So once the entire loop finishes, so once this loop is done, we need to go and assign the next generation to the current generation. So we're going to loop over all of the cells in temp grid and assign those values to grid. Oh, and I gotta close those brackets off. So those are the main 3 things that SIMPLSharp is going to be taking care of for us. So if I compile this by hitting F6, let's see if I've got any errors. Okay, so I've got one error, JNeighbor does not exist, iNeighbor does not exist. Oh, I didn't declare these at the top of the function. So let me declare those, iNeighbor, JNeighbor. So with those declared, now if I compile, I get no errors, fantastic. Alright, so the SIMPLSharp portion is done, we've compiled it. Now what we need to do is a little bit of a pain. We need to open up wherever this is being stored. Let's see. We need to open up the bin folder, and we need to copy this CLZ file from its location over to our Simple Plus folder. So I'm just using the default directory, so I'm just going to copy the CLZ file from the bin folder straight to user S+. Okay, so now that we've done that, we can now access our compiled SIMPLSharp stuff from Simple Plus. So let's go ahead and open up Simple Plus, and we're gonna start a new Simple Plus module. And I'm gonna delete most of these things, except for that blue stuff. All right, I'm gonna give it a quick name. Cool. So in order to be able to get at the things that we wrote in SIMPLSharp, we need to include our SIMPLSharp library. And then what we do is type in the name of the CLZ file without the CLZ. And if that worked, you should be able to right-click inside of the parentheses and open the API for GOL. Okay, good. So what this is showing us is all of the function names that are available for Simple Plus to call. And this toString get hash code and then this integer class ID, those are just added by default, so don't worry about them. What we care about are the set cell state, the clear, and the next generation functions. So those of you who are familiar with object-oriented programming, these functions are methods that we can call once we instantiate an object of this class. And the next thing that I'm going to do is define a couple constants. I'm going to define the one-dimensional grid size, and then I'm going to define the square grid size, which is 15 times 15, which is 225. Okay, so our Simple Plus program is going to take all of the button presses from Simple and then pass those to SIMPLSharp, which means that we need a digital input in our Simple Plus module for all of the individual cells on this grid. Which means that we need to create a digital input that allows us to set the grid state, and its size is going to be square grid size. So we've got 225 digital inputs. We also need 225 digital outputs. And then the last things that we need are inputs for the next generation button and for the clear buttons. And since Simple Plus is really weird, I have to put those individual declarations above the array declarations. So we've got our inputs and outputs declared. Now I need to instantiate an object of the class GameOfLife So how you do this is, so for a non-static class, what you'll do, we're going to look at the API for our class again. We're going to use this class name, we're going to copy it. We're going to paste it here. And essentially what we're doing is declaring a variable of type GameOfLife. So I'll call this variable myGameOfLife. And we're making this global so that we can get at it from everywhere inside of the Simple Plus module. Alright, so let's do the easy stuff first. If someone hits the next generation button, we want that to trigger the next generation function inside of our GameOfLife in SIMPLSharp. So we'll make a new event that captures pushes from the next generation button. Alright, so when someone pushes that button, what we want to do is access our GameOfLife variable, and we want to call the next generation function. Alright, and then we've also got to capture input from the clear button, right here, so we've got to make that clear button call the clear function inside of our GOL class. So we're going to add another event for the push of clear grid. And we're going to call myGameOfLife.clear. Awesome, awesome, okay. Now the last thing that we need to do is capture inputs from the individual grid units on the input side of the Simple Plus module. So we're going to start another thread-safe push event. Give it the root name of the setGrid array. And we need to capture which index of this array was last pushed. And to do that, we call the getLastModifiedArrayIndex function. There's nothing like a nice verbose function name to start your day. So now we're at a bit of a problem. Our setGrid input only has one index. But if you look at our API for GOL tutorial, our setCellState function requires two inputs, a row and a column, not just an index. So we're going to have to do a little bit of conversion. First off, I'm going to add a row and column variable. And now to convert the last modified array index into a row and column, I'm going to decrease the value of I minus 1 because digital inputs in Simple Plus are one indexed, which is weird. And my column is going to be that index value modulo grid size. And now the row is going to be the index minus the column value modulo divided by the grid size. Cool, so we've converted that single index into a row and a column. Now we just need to call myGameOfLife dot setCellState row, comma, column. Okay, very cool. We're passing all of the inputs that the module can take into our SIMPLSharp program. But what we're not doing is grabbing the current state of the grid and pushing it to the output of the Simple Plus module. So I need to add one more function, and I'm going to do that at the top. And all this function is going to do is grab every single cell state from SIMPLSharp and then push it to the output of our Simple Plus module. So we need a loop variable, and we need a row and a column variable. And our loop is going to go over all of the elements of our digital output for the Simple Plus module. And now we need to be able to get the state of a cell from SIMPLSharp and pass it to Simple Plus. But unfortunately, we didn't add a get cell state option inside of SIMPLSharp. So let's open up our SIMPLSharp stuff one more time, and we're going to add one more function. It's going to be public and it's going to be void. We're going to call it get cell state. I'm sorry, it's not going to return void, it's going to return an integer. And what this function is going to do is return a 1 if the cell at row, comma, column is alive, and it's going to return a 0 if the cell at row, comma, column is dead. If the grid value is true, we know it's alive, then we're going to return a 1. Else, return a 0. We could also do this in one line using the ternary operator. And I'm going to use this one because it looks nicer. So now all we have to do is save this, compile it, and then we have to do that whole rigmarole again. We have to open up the bin folder inside of Windows Explorer. We have to go to our Simple Plus folder, and then recopy and paste the CLZ file. Okay, so once we do that, now we can go back to Simple Plus, and if we close this API, save, and reopen the API, we should see that we have one more function, called getCellState that we can use. But our getCellState function is using the row, comma, column notation again, so we're going to copy this code over, since we already know that it works, and use it. Except for a small detail. We don't want to modify our loop counter while it's currently looping, so we'll get rid of that and replace all the i's with I minus 1. So now that we've converted I to row, comma, column notation, we can set the grid output of our Simple Plus module to our mygameoflife object .getCellState at this particular row and column. And the last thing that we need to do to make this work is call this update output function anytime a button is pushed. So when we go to the next generation, we're going to update the output. When we clear the grid, we're going to update the output. And when we set the grid to any particular value, we're going to update the output. So if we save this and compile it, we should hopefully get no errors. Oh no! Oh, my bad. So I missed semicolons at the ends of these lines. Let me go ahead and fix that. Okay, now we'll save and compile again. Everything should be okay. Good, okay. And this is something that I like to do to make things a little bit easier to find. If you go up to Edit and insert a category, I like to put this under like a weird category name like Digital Operations, so that when we go to find it later in Simple, it stands out. So I'll just recompile since I added something new. And now if I finally go over to Simple Windows, we'll see that inside of our Digital Operations folder, we only have one module, and that's our Simple Plus Game of Life tutorial. So I'll just click and drag this over to the detail view. We're going to expand the set grid all the way down as far as it'll go. Okay, there we go. And then I'll do the output by just doing Alt-Shift+ and adding 300. It'll give me an error, but that's fine. And now from our X panel, we know that we're going to be setting the grid from join 1 all the way down to 255, 225. And our grid feedback is going to go from 1 to 225 as well. So the grid feedback is going to come from the output of our Simple Plus module. We're going to set the grid on the input of the Simple Plus module. Careful to drag these to the right values. And then we need to add our button inputs for the next generation and the clear. So next generation, what we're gonna do is something a little bit fancy. We're gonna toggle the next generation button, send the output of the toggle to an oscillator, and the oscillator will just incrementally grab the next state of our Game of Life game. So next generation, output is a toggle. That goes to the input of our oscillator with a high time of 5 ticks, low time of 5 ticks. That'll be our next generation oscillator. And that's going to grab the next state in the Game of Life. And we're going to display the toggle output on the X panel. And the clear button is going to have momentary feedback. It's going to clear the state of Game of Life, and it's also going to reset if the next generation button is set high. Simple Plus God's Willing, SIMPLSharp, and Simple God's Willing, this will all compile and run perfectly. So let's compile and upload this to, oh my. Alright, so silly me forgot that I had to resync my project because I was testing using something with a similar name and then I deleted it. Okay, so now everything should compile and be fine. Okay, so let's make sure that everything works. If I click any of the grid buttons, yes, they turn on or they turn off. They're state toggles when I click them. If I did a whole bunch and then hit the clear button, yep, they all go to nothing. Now let's see what happens if I actually put in a figure who's supposed to repeat. So white cells are live, black cells are dead. If I set the next generation button high, woo, we see that little guy crawl across the screen. This guy's actually called a glider. It's kind of a neat thing. And what's more important is that everything worked. So our SIMPLSharp stuff works, our Simple Plus stuff is able to access things from SIMPLSharp, and then Simple is able to get into the stuff through Simple Plus. So things to keep in mind when you're writing SIMPLSharp libraries. If you're not using SIMPLSharp Pro, be aware that once you compile, you will have to copy your .clz file over to wherever your Simple Plus modules are being accessed by Simple Windows. If you don't do that, you won't be able to access the API that's generated from the CLZ file. The other important thing is that when you do add that SIMPLSharp library to Simple Plus, if you right-click inside of the library name, you should be able to open the SIMPLSharp library's API to see the names of the functions that you can access in Simple Plus. And the last thing to keep in mind, and probably the most important, is that not all data types inside of SIMPLSharp are directly related to data types inside of Simple Plus. For instance, Boolean values, although they exist in SIMPLSharp, do not exist in Simple Plus. Well, that's going to do it for this video. If you enjoyed it, give us a like. If you want to see more, hit the subscribe button. And if you want to see something else in our videos, leave us a comment below or on our Twitter or Facebook or Tumblr or Instagram pages.